Hello, welcome to one and all. In this class, we are going to discuss about what is meant by microprocessor and what is meant by microcontroller and what are the basic differences between them. Okay, so this is the basic diagram of a microprocessor and microcontroller. See, generally we all are using the computers. Okay, that may be desktop computer, see, or laptop, whatever it may be. For example, take the desktop as a best example. Generally, in a desktop, you can see we will have one component called we generally use it as CPU. Okay, so it will be placed below the table, and the monitor will be placed in the above the table, and all the components are going to be connected one another. Okay, so generally microprocessor is nothing but a CPU on a chip. That means we will having only the central processing unit that is present in a chip. Then it is called microprocessor. Okay, microprocessor itself cannot perform any tasks because only CPU cannot do any operations. Okay, if it want to perform any operations, it needs input devices for giving the inputs. Okay, and output devices for giving the showing the result, and there should be a memory in order to store the data and retrieve the data whenever there is required. Okay, so in that memory there will be a temporary memory and permanent memory like RAM and ROM. Okay, and along with this we need a clock that indicates the speed of operation, timers, counters. Next, generally we will give the analog data, but these computers or tabs, whatever they may be, those all are digital devices. So we need an A to D converters. That means analog to digital converters. So all these are going to be interfaced or connected externally to a microprocessor, because microprocessor means only CPU will be present in a chip. In the available silicon chip, we will get only a central processing unit. It itself cannot perform any operations completely. It is not a perfect computer to compute. Okay, in order to compute something, it first of all it need an input. The input will be given by input devices. Okay, and the input will be processed by CPU, no doubt at all, but the output should be displayed, or it should be given in the form of sound signal or in the form of some picture like that. Okay, so we need an output devices like monitor or printer or a loudspeaker like that. Okay, so output devices are also mandatory. Along with this, in order to store the data, we need memory devices. Okay, there are two types of memories like RAM and ROM. RAM means random access memory, ROM means read-only memory. RAM is a temporary memory. It is also called as volatile memory. That means whenever the power is available to the processor, it will exist. Whenever the power gone, the unsaved data will be lost. ROM means it is a permanent memory. That means it will reside even the power is switched off. Okay, along with this we need timers. Okay, so crystal oscillators or something like that we need to use to view the it will be used as a timer. This indicates the speed of operation. Okay, along with this we need A to D converters, analog to digital converter, because the input will be in analog form in 90% of the cases, but our processor will process only digital data. So in order to convert the analog data into the digital data, we need D to analog to digital converters, that is nothing but A to D converters. Next, once the CPU processes the digital data, if we give the digital data as it is to the output, our device cannot, that means for example, it gives a sound signal in the form of digital to a loudspeaker. Okay, but that digital signal we cannot understand. For example, if they are playing some song, if it is in the digital form, we cannot understand. One cannot understand the digital song. Okay, or if it gives the digital data in a monitor output, that means if I asked to perform some operation on a text, and if it gives the output in the form of binaries, zeros and ones, I cannot understand the text. So again at the receiver it has to be converted into D2A. I need D2A converter to convert the digital data into the analog form. So these are the devices that are need to perform any task, minimum requirement. But in the microprocessor, we have only processor that is present in a chip. All these components are going to be interfaced or connected externally to the microprocessor. This is the basic concept of a microprocessor. But coming to the microcontroller, the situation is different. We are having a single chip. We are having a single chip in this particular chip itself, we are having in this particular chip itself, we are having all the components embedded on it. We can see processor. Along with this, we are having what we will call I/O devices. That means input devices are there, output devices are there. Along with this memory, RAM and ROM, like temporary memory, permanent memory. Along with this serial interface, it includes A to D converters, D to A converters, or serial to parallel converters, parallel to serial converters, whatever it may be. And we are having timer. If all these components are present in a single silicon chip, then it is called microcontroller. This is the basic difference between a microprocessor and a microcontroller. Microprocessor means there is only CPU that is embedded on a single chip. All the rest of the components that are required for performing a operation are going to be connected externally. The best example is the desktop computers that are available in the college laboratories. In that you can clearly see that there will be a processor that is present in the what we call down of your table. Up of the in the top portion of your computer table, we are having a what we call monitor present. The CPU will be present in the downside. You can observe a lot of wires like power cables, okay, CPU cables. Next are connected to the from the CPU to the devices, and you can see USB mouses. If there is a printer, then a printer is going to be interfaced externally by using a wire through to the CPU, mouses, keyboards. Okay, all these are connected externally. If you wanted to listen some music and you are having a high resolution speakers, you can attach speakers also. These all are interfaced externally. That is the concept of a microprocessor. But if all the components are present in a silicon, a single chip, then it is called microcontroller. Okay. Next, coming to the basic differences between a microprocessor and microcontroller. The first difference is microprocessor is nothing but CPU on a chip, whereas microcontroller is nothing but a computer on a chip. Because in a microcontroller, it consists of all the components that are required for a computer. Okay. Next, coming to the other features, microprocessor is used for a general purpose. That means it is an all-rounder. It can perform multiple operations. For example, in our college laboratories computers, we can see C program can be installed on the same computer, Java, Python. Okay, all these softwares along with this ECAD software, multisim software, like this are TASM software, whatever the same computer, there will be multiple number of softwares that can be present, and we can run any software at any required time. That means and along with this we are having MS Word, MS Excel, .NET, C, Java, Python, Oracle, whatever. These all are can be run in a single computer. That means it can support multiple number of operations. If then it also supports CAD, like mechanical people they can use CAD or something like this. So robotics also, it can, the same system will support robot laboratories for robotics, for mechanical students. All this will be supported by a single processor. That means it is used for the general purpose. Whereas coming to a particular microcontroller like 8051 or PIC or ARM controller, these are used only for a specific task but not for a general task. Okay, so these are used for process the general task. These are used only for a specific tasks. And these differences we have already discussed. There is no inbuilt memory in a microprocessor because microprocessor is nothing but a CPU on a chip. Memory, I/O devices, A to D converters, D to A converters, counters, timers, whatever are there, they are going to be interfaced externally. Whereas coming to the microcontroller, we are having input RAM and ROM memories. Okay. Next, these are used. See, general purpose computers means personal computers. Special. These are used for the special purpose like washing machine, home automation. Like means these are a small individual device. Washing machine is a device which consists of a microcontroller because washing machine will perform only 2 to 3 tasks. That means washing the clothes, drying. That is the task it will perform. Before that, it will take automatically the amount of water, and if you select hot water, it may take, it may boil the water or whatever it may be. It will perform only this task. What is it? Washing the clothes and drying itself. If it is an automatic, that means its purpose is very limited. It cannot do multiple or more tasks rather than this. So it will perform a specific task like AC. Air conditioning is there. The main purpose is maintain the condition of a what you will call temperature constant. Along with this, we can keep some options like swing or whatever it may be. Except that it don't perform any other tasks. So it is a specific purpose operation will be performed by a microcontroller. So complexity, as it is going to perform many tasks. Just I have told that a single computer is there. It will perform C, Java, .NET, Oracle, Python, ECAD, what we call PASM software. It can support PASM software. It can support Xilinx. It can support Vivado, or it can support mental graphics. It can even support robotic software, whatever. So single processor has to perform all the support all these tasks, means it needs a large number of it is more complex and it requires a large number of instructions. Whereas I have told that it is an AC. For example, if you construct an air conditioner in our home, the main it has only little number of instructions like how much cool you have to place, whether you have to place it in the swing mode or what, whether you want to keep it as an auto mode, or if you want to set an alarm, you can set the alarm. These are the things we can do, except that there are not much things we can perform on an air conditioner. Similar task with a washing machine also. If you are having a washing machine, it can we can have only 10 options or no like that. Okay, like whether we have to, how it should wash. The clothes are very dirty, or they are what, or we are using any wool clothes, then we will select one option. Okay, if you want a hot water, then we can select other option. Okay, like that there are only few instructions that are present. So few operations it can perform this microcontroller. So obviously the number of instructions that are required are also very less. Automatically complexity is also less in a microcontroller. So less complex, less number of instructions are present. So cost will be, microprocessor will be very high. It will be in the thousands, like 5,000, 10,000, 50,000, or 3,000, 2,000, depends upon the processor. Advanced process may cost up to 8,000, 10,000 also, like that. Whereas a microcontroller, that means see, the washing machine itself costs about 10 to 15,000 nowadays. If you take any not branded one, local manufacturing one, it will come for 10,000 also. Fully automatic washing machine, 10,000, 15,000. Below that only you can get. So in that amount, the microcontroller will be only in hundreds, or mostly 1,000 rupees or like that. Okay, so it is very less cost microcontroller, whereas microprocessor has to perform many tasks, so it requires many instructions. It will be high cost. Efficiency. Generally, microprocessor will be less efficient, whereas microcontroller is more efficient. This example we can say very easily. For example, in your intermediate, you can observe a faculty coming and teaching you a subject. If, for example, if he is teaching any physics subject and he is having 20 years of experience, so he don't even, or if he is teaching any mathematics subject and he is having 15 years of experience like that, he don't even see the question also. He just reads the question and automatically he will write step by step in a board without thinking anything. Okay, how can it is possible? Means the same person is teaching the same subject since from a long time, and at a time you can see the same faculty used to teach or take 4 or 5 classes at a day to the same and teaches the same subject. So automatically he will become what we can call expert in this. Okay. Whereas if you consider any BTech faculty like that, he is a faculty with 5 years or 10 years experience. If you observe any BTech faculty in not a standard college, in a normal college, one sem he will go to the second year, first sem. Next sem he will go to the third year. Afterwards, sometimes he will go to second year again, or final year again. Sometimes he will again go to the third year. Like that, he can teach multiple number of subjects. Okay, for example, if you consider take any EC faculty who is having some 5 years or 6 years experience, he can teach multiple subjects like EDC, ECA, LECA, PICA, control systems, radar systems, like that. But he may not be expertise in a subject, because in this current sem he may teach analog communication, what we will call in this sem he may teach signals and systems. Next sem he used to teach analog communications. The next year he may not get the signals and systems. On that year he may be asked to teach some digital communications, like that, to some other. And in the second sem he may be asked to teach some microprocessor, like that. That means he may get expertise in different subjects, but he may get knowledge in different subjects, but he cannot get expertise in a single subject also. Okay, so that is the main efficiency will be less in microprocessor because it has to perform multiple tasks. If I am going teaching multiple subjects, I can have knowledge in all the subjects, but I cannot get expertise because I am not concentrating in a single subject. This time I will learn some knowledge in a subject. Next time I will go to another subject. Like this, it will happen. Okay. Next, architecture. It will microprocess follows one human architecture. That means we are having a same memory. In that same memory, we can store both the programs as well as data. This is very complicated because once we want to retrieve the data, it will be a very much big task. Because if I want to retrieve a program or data, I have to search the entire memory. Whereas in a microcontroller, it will follow Harvard architecture, which is very easy because there will be a separate program memory and data memory. If I want any program to be searched, it will be searched. I can search only in the program memory. I don't bother about the data memory. If I want to get some data, I will search only from the data memory. I don't bother about the program memory. So it will be easy now. That is the concept. Examples for microprocessor is 8085, 8086, 186, 286, 386, Pentium, dual core, Core 2 Duo, i3, i5, i7. These all are the examples for microprocessor. Whereas the coming to the concept of microcontroller, 8051, PIC, PIC, some of the ARM controllers will be there, process both will be there in ARM. So these are the examples for a microcontrollers. Okay. Next, this is the evaluation of a microprocessor. So first of all, we have told till now we have discussed about what is meant by microprocessor and what is meant by microcontroller and what are the differences between them. And this is the evaluation of a microprocessor. See, Intel is the leading processor manufacturing company even today also. Semiconductor manufacturing company even today also. We can observe most of our processors are from Intel company. Okay, so they have R&D cell and they try to. So even before 1971, there is no concept called microprocessor. Generally, for performing any operations, there will be just like what we can call calculators, which can perform only some operation to some extent. Okay, there won't be any intelligent device which can perform multiple operations. Okay, so R&D cell of this Intel company, they have tried to introduce or to implement or to introduce a new device which can perform multiple number of operations. For that, they tried in 1971. Initially, they introduced a microprocessor called 4004. It is a 4-bit microprocessor. See, this what is meant by word length? It is very important. Word length means how many, as we know that in the computer is a digital device where data will be converted in the form of zeros and ones. Okay, either 0 or 1, we can call it as a bit. Okay, so what is meant by 4-bit microprocessor means at a time we can process, it can transmit or it can process whatever you call. Okay, 4-bit of data in a single clock cycle. At a time, it can transmit only 4-bit of data at a time. Then it is called 4-bit microprocessor. If it is able to transmit or if it is able to process 8-bit of data in a single clock cycle at a time, then it is called 8-bit microprocessor. Generally, the word length will be depending on the number of data lines. Generally, the word length will be generally, not in all cases, but it will be dependent on the number of data lines. Okay. So 1971 they tried 4-bit microprocessor. This is first commercially available microprocessor, but this is a failed version. This is a failed version. Okay. So next, this is failed version. Next in 1972, they have introduced, that means though there is a failure, they haven't gone back. They have again furtherly researched. In 1972, they introduced a microprocessor called 8008, which is of 8-bit microprocessor. That means there are 8 data lines which can transmit 8 bits of data simultaneously or which can process 8 bit of data simultaneously for performing addition, subtraction, whatever it may be. It can, what you will call, perform 8-bit operations simultaneously. But this is also not up to the mark. Okay, Okay, better than compared to 4004, it is somewhat better, but it is not up to the mark because they have their expectation is much more. That means a single processor should perform all the operations. It should be used. It should generally replace the human being. That is the main concept, or it should what you will call reduce the burden on a human being. But this is also not up to the extent. Generally, these microprocessors are used in the toys where kids can play. Okay, in the kids playing toys are small devices they have used, but not on the big devices like what will the lifts or escalators or something like that. In the big devices or large devices they haven't used. They were used only in the child toys or something. After some modifications in 1974, it has introduced one more microprocessor called Intel 8080, which is of 8-bit microprocessor. This is also general purpose microprocessor used in early computers, but it also don't have much more what you can call it also don't have much more usage. There are very large number of drawbacks. Okay, in this between I haven't mentioned here there is an 8085 microprocessor. I have made videos on it also. There is an Intel 8085 8085 microprocessor. It is also 8-bit microprocessor. This Intel 8085 microprocessor is the first successful version microprocessor. I have made a separate video on this 8085 microprocessor previously. You can go through it. This is the first success version of a microprocessor where it is used in the computers for a long time. Next, followed by you can see up to 1974 they have implemented so followed in 1978 they have introduced one more microprocessor called Intel 8086. This is a 16-bit microprocessor. Why this is the main see in any textbooks or in any syllabus they will start with 8086 microprocessor. Okay, so in order to know why we come to 8086 microprocessor means there are some drawbacks in 8085. What are the main drawbacks in 8085 means it is an 8-bit microprocessor. That means it can process only 8-bit of data in a single clock cycle. That means its speed is very less. Its speed is very less means it takes lot of time for completion. Next, there won't be any proper instruction set for performing multiplication or division operation on signed numbers. Signed numbers are nothing but negative numbers. So if you are having any negative numbers, there won't be any proper instruction set for performing multiplication or division operation. Okay, is it clear? So, and there is no pipelining concept. Pipelining means one instruction is in execution mode, the other instruction should be decoding, and the other instruction is fetching. Like this it happens, then it is considered as a 3-stage pipelining. In some stages we are having 5-stage pipeline. That means multiple number of instructions are being under operation simultaneously. One instruction may be fetching, the other may be in decoding state, another may be in the executing state. This automatically reduces the number of clock cycles that are required to execute an instruction. It automatically increases the speed of operation. But such kind of pipelining concept is not present in 8085. Once it is an 8-bit microprocessor, that okay, so it can process only 8 bits of data at a time. So automatically what happens? Automatically speed will be reduced. Second, there won't be no proper instruction set. We cannot perform signed multiplication and division operations properly. If there is any negative number, if you perform if the two operands in for multiplication, if one of the operand is negative, the answer may come abnormal result. Okay, similar concept with the division also, and there is no pipeline. These are the drawbacks of 8085. So we came to 8086, which is 16-bit microprocessor. That means it can process 16-bit of data in a single clock cycle. Automatically speed increases, isn't it? And there is a 3-stage pipelining in 8086. Automatically pipelining concept also is used, and there are IMUL, IDIV, integer multiplication and integer division operations in 8086. Automatically that problem also eradicated. Okay, so this is also, this we will get in the syllabus. In most of the colleges have this 8086 microprocessor in their syllabus. So before going to 8086 we have to know why 8085 is not used. Okay, later we are having 80386 32-bit microprocessor, and 1993 Pentium. 2006 onwards we are having a dual core 4 to duo i3 i5 i7. These are the different processes that are present. Okay. So thank you very much.